show, now that we've got all the friends online, something that I'm going to send to everybody once class is over is my fully worked out solutions to these practice multiple choice questions that we've been doing, as well as the practice free response questions. So you're going to have access to all of that information, not just the answer, but like the work that supports the answer. This would be excellent study material. There's like 15 questions that I haven't asked you to do for homework. I'm not telling you do them this weekend for homework, but Andrew, that would be a really good idea to do those extra problems, and you'll have the worked out solutions for support. This weekend, if you need some help, if you're just like, hey, I'm really stuck in a question, do what Stephen does, do what other people do, take a little picture, send it to me, I'm stuck here. This applies to my North Central friends and my East End friends. If there's something you're not sure about, just email me. I'm going to be out and about doing all sorts of family stuff. Caroline takes ACT tomorrow. Yay! But I can definitely support email. All right. Next order of business. This impacts everybody. David, since you're wounded, I'm going to do this for you. We need to put calculators in press to test mode. Thanks, sir. Okay, Andrew, do you want silent study hall? No, wait, do you want silent study hall or collaboration time?
Collaboration.
Okay, because you selected for first name, last name. That's okay.
My name is Irene.
All right, Aaron, I'm going to do this for you because I need to model for somebody. Oh, David, sorry. Sorry. Okay. All right, so, and if we can turn that off. Every single person needs to have their calculator in press to test mode. Steve, if you can turn it off.
It's not your calculator.
Okay, well, so here's how it works. You got to pay attention, otherwise you are going to shut off features on your calculator, like, for example, doing anything with the tangent function. Don't do anything unless I tell you to do it. So, turn your calculator off.
Just on the right.
Yep. Okay. Whoa. Yeah, let's take a little bit. Okay, calculator off. Yeah, that's not better at all, is it? Calculator off. Now, using okay. You need two fingers. One for escape, one for on. Hold them both down until the screen comes on and it takes you in press to test mode. Okay? It's two fingers. Do not use the enter button at any point in this next thing. You will tab and you will only tab. So angle setting, it says degree. We're in a calculus class, we know better. Radian. So do not use enter, just use tab. Select additional restrictions. If you want your calculator to do less than it normally can do, keep them all checked. Instead, what you want is you want to tab and click the little middle button to take the check mark off. Tab, middle button, tab, middle button, tab, middle button, tab, middle button, tab, middle button. All the way down. Uncheck those things. If you decide to leave any of those things checked, your calculator is less powerful. Okay, hit tab one more time where it says enter press to test mode. This means that you mean it. You are actually going to go into press to test mode. Ready? Enter. Okay, and it's going to shut down. It's going to reboot. And it's going to awkwardly pause.
Gorgeous.
Okay.
Oh, it's wicked.
Okay, please show somebody near you that your calculator is blinking. If your calculator isn't blinking on Monday, you can't use it. I will take it away. All right, so here's the last thing. Sometimes when you put your calculator in press to test mode, you lose the settings that you want. Meaning like it flips out of fixed mode and it goes into float mode. All your answers on the free response have to be accurate to 3 places after the decimal. So let's go through and let's check that. Let's make sure that you're still in fixed mode.
Float. I mean, okay.
Not float. The only thing around here that floats is me. Okay, settings,
I'm okay.
document settings, fixed 4. So it looks like on David's calculator that the setting didn't change.
Okay, fix 6.
Okay, or fix 6, that's great. You should also go over to your graph mode because some of you have the more updated software and you have settings down here as option 8. Make sure that you're in fixed 3 or higher mode as well. We are in fixed 3 mode, we're in radian mode. These, you're not going to be able to see it too clearly up here. Fixed 3 or greater. So fix 4, fix 6. Okay. Everybody good with press to test? No problem. Alright, cool. For those of you that have a charger, charge it this weekend. Like the blinking isn't going to drain your battery, but you are going to use more battery than you normally would. I will make sure that Monday in the cafeteria I have the charging station with me, but there's only 10 spots and there's 11 of you. Yours is fully charged. Excellent. Alright, we've talked about solutions, we've got press to test mode. 2 more things I want to accomplish. Number 1, well, 3 things is I want to eat a kolache. Does anybody have any questions about the exam on Monday? Like things that I could answer?
Oh, thing.
What can you answer?
You can ask anything and I can say yes I can or no I can't.
Is that
Questions about structure of the exam, questions about content of the exam. Celeste.
Do the questions get harder like as you go through or they don't?
The thing I'm supposed to say is they don't necessarily go easy, medium, hard, impossible, but usually easy questions happen in the beginning and then they do get a little bit harder and they get a little bit harder, but there are some medium questions sprinkled in towards the end. So don't necessarily assume that the last question is the hardest question. That's not true. Okay? You want to make sure that in the time that you have, you see all the questions. Because you never know. There might be something that is your jam that is hard for somebody else that is at the end of the test waiting for you. All questions are worth the same number of points and there's no guessing penalty. Lewis.
What unit questions are there more?
That I can't really answer, but I will say that I think all 5 units are really important. Unit 1, limits and continuity and asymptotes. I think it would be a wise choice for the 11 of you and all the friends at home to spend some time this weekend going back to Unit 1. Because there are going to be things like asymptotes, relative growth rates, definition of continuity, right? Things that we haven't really worked with since August that you were good at some point, but that was August. I would spend time on Unit 2, all those FF prime, F double prime relationships we talked about yesterday. You want that to be solid information. You want to see a question like that and be like, got that. I'd also want to make sure that when it comes to the derivatives, you know every single derivative rule and you are not worried about derivatives. You see a derivative question and you're like, I know I'm going to get this one right. Inverse trig will be on there. Unit 4, that's the scary one. That's applications of definite intervals. Related rates, implicit differentiation, L'Hopital, mean value theorem, extreme value theorem, optimization. We're going to do an optimization question today. Okay? Unit 5, definite integrals, Riemann sums, average value theorem, the infinite case with Riemann sums. Like, it is a complete test. Okay? But I would really make sure Unit 1 is solid because those can be the easy questions if you studied and you're confident. Okay, other questions about the exam?
Integrals aren't going to be on there, right?
Integration, like integral of cosine of sine of x plus Charlie, is not going to be on there. Okay, it's the first 5 units only. Okay. Anything else? Kids at North Central and East End, if you have a question about the exam, email me.
Bless you.
Are we supposed to have memorized the arctan or cos and those?
I think that would be a good choice. Or you could derive them for yourself.
Or you can memorize them.
Or you could just memorize them. I mean, that's like a thing. And that would like that would be a good thing to do maybe like right before the exam. Like make sure you're fresh on all those things. Find somebody to study with. Okay. Any other questions? Alright, let's check the homework. Alright. So I'm gonna stand over Eilay's shoulder. Oh wait, yeah, you guys have the tally sheet. I'm gonna stand over your shoulder so I can see the question numbers. Okay, question number 21 is A. Number 25, also A. 27, D for dynamite. 29, B. 30, J. 32, G. 33, C. 39 is the next one? 39 is D. I'm curious, how'd you guys do on 39? Good. Okay, and now it's like 40 to 47, right? 40 is G. 41 is B. 41 is B. If anybody picked... Oh, it wasn't even one of the options, was it? Okay, I was being kind there. Never mind. 42 is H. 42 is H. 43 is A. 44 is G. 45 is A. 46 is J. And 47 is C. Okay. Please, let's get this part right. I want you to do the tally. So you're going to go through and indicate, did you get it right? Did you get it wrong? I'm also interested in your doing the tally at the bottom. The reason for you to do the tally at the bottom is more for your benefit than mine. If you got all 3 questions right in Unit 1, that's a good sign that you know what's going on. Okay, I'll pick this up in just a little bit. Oh.
Strong score. How'd we do?
God, I love Pilates. Pilates has helped make me into the man I am today.
Test next week.
Alright, are there any questions that we need to talk about? Any requests for problems that we need to talk about?
25.
20. Okay, I heard a double request for 25. So I'm going to talk about 25. If you don't need to talk about 25, no problem. Work on something else. I'm only going to go over like 1 or 2 questions, but find something else to work on if you don't need help on 25. Who are the folks that need help on 25? Lewis? David? Okay, friends over here. Okay. So you all have at least 2 options for figuring out a problem like this. If I look at 25, I look at limit as h approaches 0, cosine 3 pi over 2 plus h minus cosine 3 pi over 2 divided by h. I would hope you would see it in one of 2 ways. It's either a limit question that you're going to try to evaluate. Did anybody actually try evaluating this?
Oh, I
You
did.
thought about it. Okay, like, but for folks that get this wrong.
No, I didn't. No.
If you evaluate this limit at h equals 0, you get cosine 3 pi over 2 minus cosine 3 pi over 2 over 0. Guess what? 0 over 0. So what do we do? L'Hopital. If you're going to use L'Hopital, L'Hopital says take the derivative of the top, which is going to be negative sine 3 pi over 2 plus h, minus derivative of cosine 3 pi over 2, which is 0, divided by the derivative of h, which is 1. That's one way. Here's the other way. I asked you guys to do this like back in Unit 3 before there was L'Hopital. Before L'Hopital was in your life, this would be the kind of thing that we called, Ms. Blakely likes to call it a sneaky derivative question. This is that limit as h approaches 0, f of a plus h minus f of a all over h. There were like 3 ways that we talk about finding derivatives. This is one of those derivative forms. And so what I'm asking you to find is the derivative of cosine of x, because cosine of x is your function, evaluated at 3 pi over 2. L'Hopital's rule would have been better, but if you see it as a sneaky derivative, that's okay too. Okay, we get time for one more. Yeah, please don't take the derivative of a number and get something not 0.
Yeah.
29? Oh, 29. Oh boy. 29 is a rough one. Stephen, if I'm over here, can they see? Okay, so I'm just going to get you guys started, and we're not necessarily going to finish this one because it's going to take more time than what it's really worth. Okay, so I've got the parabola y equals x squared. Okay, so here's the parabola y equals x squared. We've got the point 0, 2, and the question being asked is what point on the curve, like what point on the curve is the closest to the point 0, 2? This is an optimization question. And the way that I know it's an optimization question is that word closest. Right? You want best, you want biggest, you want smallest, you want farthest to the left. These are all optimization conversations that we're going to have. So what I need is to figure out how do I calculate the distance between these 2 points.
Pythagorean theorem.
You could use Pythagorean theorem if you think about it that way, or you could think about this as like a distance formula kind of deal. And so the distance formula says that's the square root. You look at the difference in the x values, x minus 0 squared, plus the difference in the y values, y minus 2 squared. That's what your distance formula says. I want to take a derivative, and there's a problem with taking a derivative here.
2 variables.
You get 2 variables. You got to get rid of one of them.
We just cross out the y.
Cross out the y? No. Get rid of the y, replace the y in a really smart way. That's the good thing to do here. Not dy dx.
Oh.
You need to be able to connect the y and the x together. Lewis, what do you say?
Plug in x squared to y.
We know that y is equal to x squared. If it's a point on the parabola, that y is equal to x squared, so like this guy here. So then your next move is going to be find the derivative, set it equal to 0, solve, and then do a little thing that I like to call pray. Because that is just one mean question. Alright, I want to call time on homework. So if you can put tally sheet in the middle of the table. You're going to get this back from me. Stop by during lunch, I'll give it back to you, but I want you to have the problems. If you've made corrections to something, put that in the middle of the table. And here's what I'm going to ask you guys to do so I can stop talking and you guys can do some working. Okay, between now and 9:20, I want you to decide which free response question do you want to work on. Question number 50 was on last year's trimester exam and showed up on there for a couple of years. This first question tests some Unit 1 stuff. So question 50 is an option. Okay, we've also got question 51 that involves implicit differentiation. This could be a really good question for you to get some practice with. We've got some good skills built in. You could, let's see, 52 we've already done. 53 you guys did last night as a bonus. Okay. 54, we're going to do it at 9:25.
54 is the optimization question.
54 is an optimization question. That one we're going to do together. So choose from one of those problems. All right, I think those are the only problems we haven't done at this point. Right, either 50 or 51. And I'm going to ask you to like split the group a little bit. If you're going to do problem number 50, where are those folks? Okay, question number 50. Is everybody else doing question 51?
Yeah.
Okay, so then Stephen, maybe why don't you scoot to the back? You're going to join him. I think that's a really wise choice. You guys get 10 minutes to work on either question 50 or question 51. I'm going to finish my watching.
Please. Does anybody else need blank sheet paper? Alright.
Your secret Santa just doesn't stop.
No, this is for us.
Oh. I'm using exterior representation. This isn't the x axis, it's the y axis. And I'm asking you about the position at these different times. I will on the other Okay, and for the friends at North Central and East End, seriously, if you have questions this weekend, please email me. I will email you back. It's going to take a little bit of time.
Because I remember
Oh, wait, Oh, wait.
I think you can take.
Oh, you're taking the derivative of everything, right? Time? 1 year?
No, I don't. No, I'm doing it.
Oh, wait.
You take the derivative of y.
Because I have the 8y. I have 2x.
2x plus 8y equals 0.
Y. Oh, these are the zeros.
Yeah, like, leave, wait,
But did you just get that from looking at it?
Oh, wait, that's it.
You have to check that.
I love the solution sent out to them. Yeah, good.
Wait, what did you get? Oh.
Alright, you.
The reason being
Alright,
is
yeah, my bad.
the relationship
Yeah, my
between
bad.
acceleration and velocity is a derivative. Okay? So I'm asking you to approximate the derivative of the velocity. And what I have is I have points in the velocity function, but how am I going to get to the derivative of the slope? Okay. So you need to pick 2 points that are closest to 9, so like 5 and 13. And if you find the slope of the line that connects these 2 points, what you're really finding is the slope of the slope.
Yeah. Get out of here.
I see what you're doing here is like you're finding the equation of the tangent line, but the equation of the tangent line, if you plug in 9, this is going to give you an approximation for what the velocity is, not an approximation for what the acceleration is. Okay?
Friends over here, how are you?
I mean, you can find, I know you can find all this, but there's something.
So if I'm gonna take the derivative of
But when you have
x
a y,
Times
you want to do y
okay, I think part of it you just need a little bit of time to start.
No, you see the Y.
Oh.
But yeah.
2x, what's the derivative of 4y squared? Not
'Cause I think I turned.
because you're saying, let me take the derivative and do what I normally would, which is bring the power down, reduce the power by 1. But then I have to remember that y depends on x, so it's going to be times dy by x. Okay, and then derivative of 7. Yeah, and derivative of 3xy. See, when I see 3xy, I'm thinking to myself, this is 3 times x times y. That would make it be Yep.
So,
I see you're okay.
would it still be right? If it was 2, but if it was 2x minus 3y over 3x minus 8y?
So,
So it was on Unit 4.
algebraically, my fear is that this statement here says, show me this is true. And if you do anything less than showing that this is what the derivative is, there could be an argument for, oh, well, she took the derivative and she did some stuff, but she doesn't actually understand
Alright,
that your answer is the same as this one.
okay. So even if it's right, like if they want this, like,
If this is what they
Oh, I
want,
get it.
give that to
You
them.
have to get those
Don't give them
together on
something
the
else.
same
So, like, what if it was
side
just like-
and this out.
like asking what is
What
the
does it
thing,
Oh, right,
And all I
if the
get is
question was, how do you write
Okay, okay,
yours?
never mind. We don't-
Then what
So we
you
need to
had,
just
so like this guy here, or the flip everything around,
right?
those are algebraically the
Minus
same.
Okay. So then,
Does that make
in
sense?
that case, it would, it would
Yeah.
get multiplied, but if they
Right.
want this, then give that.
Right, because those are two very different questions. One says find dy dx, basically express it any way you want to, and the other is like find it and show me
Yeah, we
that
can
this
do
is
that, but I was
exactly what
like-
it's equal to.
Okay.
I was trying to look for the division.
I mean, yeah, you're gonna divide.
So, yes, and a little bit no. Okay, so it looks like, okay, I see what you're doing. You're doing like extended product rule, which is fine. So 3 times derivative of x is 1, times y, love it, plus 3 times x, what's the derivative of y?
Oh, dy dx.
dy dx, that's why I need the dy dx. Friends over here? Yep.
Whenever you take.
So derivative of x squared, 2x, nice and easy. Derivative of 4y squared, this is where things get a little tricky. So the question is, what is the derivative of 4y squared? Well, how would I normally take the derivative of something like 4x
It was
squared?
like hanging on.
It's a power rule, right? The power rule says bring the power down, reduce the power by 1. So that would lead me to say, oh, the derivative is going to be 8 times y. But we need to remember that y is a function of x. Y depends on x. So we multiply by dy dx. Because basically what you're doing a chain rule problem. You're seeing, anytime there's a y, we need to have chain rule thoughts. Where the y is the baby.
8y times dy dx.
It's just a lot.
Because basically you're saying like, let y be the baby in this chain rule problem. Bring the power down, reduce the power by 1, don't do anything to the baby. Times the derivative of the baby. Okay. Alright, Lewis.
We figured it out.
You figured it out, sorry. I'm sorry?
Alright, friends. It's time. It's time. Yep, we're going to go over to question number 54. Okay. And I want to invite you to do this on your own if you want to. Please do me a favor, cover up or black out the objective function. Like last year when this question was on the test and I just knew it was going to be a bloodbath, I was like, hey, let me be kind and let me put the objective function on there so that maybe teenagers will earn more points. Nah, that didn't happen. The fact that the objective function was given apparently didn't matter to anybody at all. They're just like, I still don't know what's going on.
Oh!
That's nice. What's that for? Alright, so challenge by choice. If you want to work on this one with me, and I'm going to assume that's probably where most people in the room are, let's go through and do that. If you want to go solo, please feel free to go solo. The goal is to get through this problem between now and 9:39. So before I say anything else, take a chance, read through this, make sense of what you can. So in terms of classifying this question, is everybody okay that this has to be an optimization question?
Yes.
Okay, what is it that you read, Myra, that screams optimization?
This is what are the dimensions of the least expensive?
It's this word least, this least expensive tank. This tells me optimization, and maybe this puts a little bit of fear into my heart right now, or at least the open hole where a heart would normally go. Okay, if it's an optimization problem, then our usual approach is I need a constraint and I need what we call the objective function or the optimization function. The constraint is the thing that pulls everything together. It's the thing that restricts your answer choices and says, whatever I do, however I build it, this thing has to be true. So my question for you all is, what is the constraint in this problem? Let's get some hands on this. What's the constraint? Of all the boxes you can build, there's something that has to be true. I see one, I see two, I'm going to wait for a couple more. I see three. What's the thing that has to be true about this box? Because this is going to get you on the road to some success. Myra, what do you see?
The width has to be 4 meters and the volume has to be 36 cubic.
The width has to be 4. I have no choice there. The other place where I have no choice, volume. The volume has to be 36. So my constraint is that my length times my width times my height has to be equal to 36. This is always going to be true. This is something that I can manipulate and play around with to make my life better. Now we need to figure out the objective function. The objective function, what's the thing we're trying to make small?
The cost.
The cost. So what I need to do is figure out, well, what's the cost of building this box? I've got the base of the box, and I think they told me, is it $10? Okay, $10 per square meter for the box, for the bottom of the box. So the cost for the bottom, L times 4 is going to be the area, but that's not the cost. That's the area. I need to do L times 4 times 10. Everybody okay with that? Okay. So I'm just going to call this 10 times 4 times L, and that gets me the cost for making the bottom. Not done making the box. Palamon, what's going to be the cost for making this side over here? $5 times 4?
2 times.
Hold on, just this side over here. I agree with you that it's $5 per square meter. What I don't like is I don't think you actually found the area for the side. The 4 is the width
Width and times height.
times the height, so the area here is going to be 4 times h, so 4h, at $5 per square meter. So the cost for that side is going to be what, 5 times 4 times L? Takes care of that side. Aaron, give me another side that you know the cost of.
Wait.
4 times h.
Yeah.
Sorry. Okay, Aaron, give me another one.
Yeah, the opposite side.
The opposite side, so this guy over here, how much does it cost to make this one? Same, right? So I could say just all of this doubled. Carmen, what about the front side here?
It's the same, no, would it be L times 8?
L times h is the area for the front. I need cost. So times 5. So this is going to be L times h times 5. And then is everyone okay? We're going to double that?
Yep.
Okay. Big point. I mean, just coming up with that, golly, that would be huge. And it was such a barrier for folks the year before. I'm like, I'm just going to give the objective function. I'm going to be kind. Waste of time. Okay, 40L plus 5 times 4 is 20. 20H, double that, is going to be 40H. L times H times 5 times 2 is 10LH. And no surprise, that is exactly what we had for the cost function. Okay? I want you to have a quick strategy conversation with somebody near you. What do you do now? What do you do at this point?
Yeah, you rearrange.
Where the objective functions coming from. So what's the strategy now? How do we make the least expensive?
That's what I did.
What I was doing was,
You're right, we're going to plug in the constraint. Do you remember why you're going to plug in the constraint? And if not, that's okay. Okay. The reason that you're going to plug in the constraint is to find out when the cost is a minimum. We need a derivative. We need to see where the derivative is changing from negative to positive. So why do we need to plug in the constraint?
okay, so what I was saying is,
To want to find the minimum, but what you need to do is take the derivative, and there's a reason why you cannot currently take the derivative. This function has L and H in it. You've got 2 different variables, so you can't do anything with that.
you could get 8.
Alright, so I was just having a conversation. We know we want to take the derivative. Problem with taking the derivative, we got multiple variables. So it's this multiple variable thing. That's when you're going to say, oh, let me go back to the constraint, because the constraint gives me a connection between the variables that I have. I know that, what is this, 4LH equals 36, which means that L times H is going to have to be 9. H is going to be 9 divided by L, or L equals 9 divided by H. It doesn't matter which one you're going to go with. So my new function is going to be 40 times L plus 40 times H is 9 over L plus 10 times L times 9 over L. Cost is going to be 40L. This is 360 over L plus 90. You've got your objective function in one variable. This is now finally where like the process kicks in. And the next step in the process, Lewis, what are we going to do? You've got your objective function in one variable. This is a key step. You can't go anywhere until you get here. You're trying to minimize. Somebody help Lewis out. What are we going to do? What are we going to do? No one wants to help Lewis out. So sad, Lewis. You're on your own. Stephen, what are we going to do?
Do you find the derivative and then find where it goes from positive to negative? Or the
Right.
minimum from negative to positive?
Right. What we're trying to do is find the minimum. So if what we want to do is find the minimum, we need to find the derivative. And the derivative of 40L, 40. Derivative of 360 over L, like this is one that we memorized a long time ago.
360 over L.
It should be a negative 360 over L squared. Derivative of 90, going to be equal to 0. I've got the derivative. Getting here is important. Next move.
Equals
Equals 0.
Right, figure out where is C prime equal to 0. So I need 40 minus 360 over L squared equal to 0. I'm going to go fast here. We're running out of time, but it's algebra. Fraction killers are going to multiply by L squared. I'm so proud Caroline became a fraction killer last week. I almost burst into tears as she was working through a problem, and I heard her say, I'm going to multiply the equation on both sides by the common denominator because I'm a fraction killer. Proudest moment of my adult life. So my length is plus or minus 3. And really, it's not plus or minus 3.
it's plus.
It's only plus 3. L equals 3 is the only candidate. It's the only candidate for L greater than 0. I'm not going to make a box with a negative length. This is a good thing to have happen. You have one candidate. So guess what? Careful. If this is a relative minimum,
Yeah, it's an absolute.
then it's the absolute
It's the
minimum.
only change.
If it's the relative max, it's the absolute max, emphasis on like the only. We just have to make a decision, which one? Max or min? Option number 1, I think the obvious choice here, number line test. There was another way that we used to determine min or max. We didn't do it a lot, but it had to do with the second derivative.
Oh,
There's the second derivative test. What the second derivative test says, and it's been a while since we've talked about this, it says if you know that this is where the derivative is equal to 0, then take one more derivative, plug this into the second derivative, and look at the sign. Okay, so what's the next derivative? C double prime. Take one more derivative here.
negative positive 360 over L cubed.
Not positive 360 over L cubed. It might be helpful to look at this first derivative as 40 minus 360 L to the negative 2. And now it's a power rule. Bring the power down in front. Take 1 away from the power. C double prime is 720 L to the negative 3rd, or 720 over L cubed. If this does not feel comfortable, don't pursue this option. Go with the number line test, you're going to come up with the same conclusion. So here's the question. What's C double prime at 3?
27.
It's 720 over 3 cubed. And I only care about one thing here.
Positive.
I care about positive. So think about this just for a second. We know 2 things now. We know the first derivative is equal to 0 at 3, which means horizontal tangent line. And the second thing you know? Second derivative is positive, which tells me that the original function is concave up. So think about concave up and horizontal tangent line at the same time. Right? Doesn't that have to be a minimum? So I'd say something like C has a relative minimum at L equals 3 because 2 things happen. C double prime of 3 is equal to 0 and...
Don't you,
Go ahead.
C C prime, you said double prime, right?
Sorry, C prime of 3 is equal to 0. I have a horizontal tangent line, and second derivative is positive. If this isn't the way to go, number line test is the way to go. Okay? So we've got a relative minimum. Not done.
Absolute minimum. 'cause
You
it's
need to
only
get
changes
to absolute minimum. Okay? So I'd say something like, since C prime changes sign only once for L greater than 0, this means C has an absolute max at L equals 3. And as good as that is, we're still not done.
We need to plug in,
Absolutely.
no,
Oh!
yeah.
Thank you,
But
thank you, Aaron. Absolute min.
you gotta plug in 3 back into the,
Why?
because it's asking for the dimensions, you still don't know the height.
Yeah, you always have to go back to their question. What's their question? Their question is, what are the dimensions of the least expensive tank? So dimensions, I need length, I need width, I need height. The length is, what's the length? 3 meters. The width? 4 meters. And the height?
3.
Right, you either come back over here and you say, oh, I know h is 9 divided by 3 and I get 3, or you're like, what times what times what is going to be 36. Your height is going to be 3 meters. Okay, so you got length, we get width, we get height, we get the dimensions. Still not done.
Get your money down.
How much does it actually cost to build? And I think if you do everything correctly, it's $330. Okay. Honestly, the College Board has moved away from doing questions like this, and I think part of it is there's so many pieces, there's so many places where you can go wrong, you make one little mistake, and everything falls apart. What I hope, though, is that like the individual parts make sense. You've got second derivative test or number line test. You've got finding your candidates, you've got all the things. So, before you guys take off, I just want to say thank you for an incredible semester. You guys have worked really hard. Friends on the other side have worked really hard. I've had the pleasure of kicking your collective asses for a whole 18 weeks. And why, hello, Mr. DeBella. I did just say asses. And what I know is you guys are ready on Monday. You've got some studying that you need to do this weekend. Don't spend the whole weekend studying calculus. As much fun as that would be, you're going to burn out. See you later.